All right, here we go. Slope fields. So these are called lattice points. Relax. By the way, you've seen slope fields before. We'll see in a little bit. See in real life too. Like you've probably seen them on TV. So these are called lattice points. They're just coordinate grids, and you're gonna put some stuff. It says draw a slope field for each of the following differential equations. Each tick mark is 1 unit. Okay. So they tell you, look at number 1. dy dx equals x plus 1. Notice the differential equation just has an x on it. Cool or not cool? So on the y-axis, the x value is 0. So all we're going to do, you're going to go 0 plus 1, and 0 plus 1 is 1. So you're going to put a little slope of 1, a little hash mark. So look, a slope of 1, a slope of 1, a slope of 1, a slope of 1, a slope of 1. Just a little hash mark. Let me zoom in. Do you see what I did there, guys?
When x is 0,
Because when x is 0, on the y-axis, the x value is 0. And what is 0 plus 1? 1, and this means slope. So my dy dx is always just 1 on the y-axis because the x value is always 0. Does that make sense? So let's do another one to see if that made sense. On x equals negative 1, so right here, these points right here, at x equals negative 1, negative 1 plus 1 is, so I'm going to put little hash marks of slopes of 0. Slope of 0, slope of 0, slope of 0, slope of 0, slope of 0. Do you see what we're doing? At x equals negative 2, the slope is negative 1. Negative 2 plus 1 is negative 1. So you're going to put slope of negative 1. It doesn't have to be perfect. Just make it look like negative 1, like so. At x equals negative 3, the slope is, so we're going to make it look like negative 2. Chop, how do I make it look like negative 2? Well, you just aim it right like that. See, it's a little steeper. It doesn't have to be perfect, guys, as long as we can tell, as long as it's relative to the other slope. And I fill that part in. Now let's go to x equals 1. What's 1 plus 1? So make that slope of 2. Doesn't have to be perfect. And what about at x equals 2? What's 2 plus 1? So slope of 3 doesn't have to be perfect. Just make it more steeper than the last one. And then 1, 2, 3. And then at 3, the 3 plus 1 is 4. Just make it even more steeper. Just don't make it look vertical, but, you know, more steeper. Yeah, I know. It's almost vertical there, but that's fine. That's fine. It's a slope of 4. Maybe I should have been more calm with my slopes. All right. Cool or not cool? All right. Notice, I just want you guys to notice, do you see how I have a whole bunch of parabolas here? Like, let's say they told me that I want a point going through there. Like, they want the function going through there. Well, look. Oh, sorry. Let me pick a different color. It would have looked like this. See? What if they wanted a parabola going through here? It would have looked like that. I'll just follow the slope fields. That makes sense? Cool. And notice, yeah, look, if you were to do the antiderivative of this, you would have had a parabola, x squared over 2 plus x plus c. So depending on what the c is, it depends. You're going up and down, right? But the vertex all lies on the negative 1. All your vertices of the parabolas lie on the negative 1. Do you guys see that? See how it's all coming together?
Whoa.
Okay. Okay. Let's go to number 2. All right. On number 2, this one does not have an x. This has a y. So the x does not affect this one. Cool or not cool? So on the x-axis, the y value is always 0. And 2 times 0 is? So 0. Yep. Horizontally on this one. Then we're going to go to y equals 1. 2 times 1 is... So we put a slope of 2. It doesn't have to be perfect. Just make sure it's positive. And then I go to the next one, 2 times 2. 2 times 2 is, so just make it look steeper than the one below. Okay, now let's go to y equals negative 1. At negative 1, what's 2 times negative 1? Negative 2. So the same steepness as the one above at 2, but in the negative direction. All right, what about at y equals negative 2? So negative 4, steeper, but in the negative direction. And there it is. You got another slope field.
That is pretty, huh?
How does it look so far? It looks pretty cool. Look at that. It looks really cool. All right, now we got one that is dictated by x and y. Chav, how do I do these? Relax. Look, I always like to do, here's what I like to do. I like to say, well, I want to know where these are going to equal 0. So I'm just looking at this, and I notice that I get x plus y equals 0 whenever y equals x. Do you guys see that? So along the line y equals x, all my slopes are 0. So 0 here. I'm going to go to 1, 1. I'm going to put a slope. Hold on. 1, 1 is not. How come you guys didn't tell me that's a negative x?
Negative. Oh, yeah, was the...
Yeah, negative x. Negative x. Negative x. Yeah, I was about to make a mistake, but I caught it very last minute. You guys should have caught it before me. When I move the x to the other side, it's a negative x. There we go. No one's mad. No one get mad. Yeah, no one get mad. Stop. We're good. We caught it. All right. So do you guys see along the line y equals negative x, how my slopes are 0? Okay, now everything above that line is going to be positive or negative? Positive slopes, and everything below that line is going to be negative slopes. You can just go one at a time if you're freaking out, like, I can't do it. Like, look, let's go to 1, 1. Or, you know what, let's just go along the x-axis and keep one value constant. However you want to do it, whatever you think is easier in your head. So I'm at 1, 0. What's 1 plus 0? 1. So let's make a slope of 1. I go to 2, 0. So what's 2 plus 0? 2. So I make it steeper than the 1. And then I go to 3, 0. What's 3 plus 0? So I make it steeper than the 2. See what I did there, guys? And now I'm going, look, I'm going to go, let's hold let's go to y equals negative 1 here. So I'm going to go to 2, negative 1. What's 2 plus negative 1? 1. So make it look like this one. So these two, make them look the same that I circled. I'm going to go to 3, negative 2. What's 3 minus 2? 1. These three, make them look the same. Do you see what we're doing? Okay, I'm going to erase my little circles. I'm going to go to 0, 1. What's 0 plus 1? 1. Make it look the same. I'm going to go to negative 1, 2. What's negative 1 plus 2? 1. See how they're all the same? Okay, and now we just keep going. We just keep filling them in. I'm going now to 1, 1. What's 1 plus 1? So make it look like the other two. I'm going to 2, 1. What's 2 plus 1? Make it look like the other 3. I'm going to 3, 1. What's 3 plus 1? There is no 4, so that should be the steepest one so far. You see what we did? All right, now I'm going to the line y equals 3. So 0, 3. What's 0 plus 3? Make it look like the 3. Let's see, where are the 1, 2, 3? That one, okay. And then I'm going to 1, 3. So that's a 4. Make it look like the previous one we did a little while ago, the 4. And now we're going into real steep now. I'm at 2, 3. So that's 5. And then 3, 1, 2, 3. 3, 3. That's 6. 3, 2. That's 5. Oh, wait. I messed up, huh? Because this is 1, 2. Y value. So hold on. 0, 1, 2. Slope of 2. Slope of 3. Slope of 4. So this one should be a little lower. We're good. We're good. Slope of 4. Slope of 5. There we go. Now we're good. We're good. No harm done. I can still see my pattern. Very obvious. I'm going to go to 1, 2, 3. Negative 3, comma 2. Negative 3 plus 2. Negative 1. So this one has a slope of negative 1. Oh, yeah. This is going to be a nice line. All right. Check it out. I love this one. This is going to be awesome. This one, I'm going to 1, 2. I'm going to negative 2, 1. Slope of negative 1 again. I'm going to negative 1, 0. Slope of negative 1. I'm going to 0, negative 1. Slope of negative 1. I'm going to 1, negative 2. Slope of negative 1. Wow, look at that. Beautiful. If you get a point, look how beautiful this is. If you get a point right smack at this point, look at that purple one. then that point, if they tell you to draw the function, that point's going to look just like a linear line because it just follows that slope field. Isn't that cool? Okay, just making sure you guys are having a good time like I'm having a good time. All right, I'm going to go to negative 2, 0. Negative 2 plus 0, that's going to be negative 2. So let's make it look like a negative 2. And then I'm going to go to negative 3, 0, so negative 3. Cool or not cool? All right. Negative 3 plus 1, negative 2. Let's see. Now I'm at negative 1, so negative 2 again. Negative 1, negative 2, that's negative 3. That's too steep. There we go. Negative 2, negative 1, negative 3, so like that one. Negative 2, negative 4. And then this one's the most steepest. Negative 3, negative 2 is the most steepest. And then negative 3, negative 1, negative 4, so boom. And there it is. And there's another one. It's supposed to be steeper the further down left you go and steeper the further up right you go. I didn't do the most awesome job, but that's fine. And then negative 2. This one's negative 2. All right. Which one? Oh, yeah. 1, 2, 3, 1. So 2. So something like in between that and that one. There we go. Looks good. And you can see it. I didn't do the. I've done better graphs. This one's not as good as I wanted it, but that's fine. Well, check it out. If you keep the x value, if you keep the y value constant, but you move up on the x, notice it gets steeper. If you keep the y value constant and you move left to right, notice it gets, well, it moves from. You guys see that? Cool, right? And then the same thing applies. Look, going down. See, like so. Yeah, it's cool. Yeah, I've done better graphs, but it works. This one works. Full credit. All right. Let's see. Number 4. This one is just evaluated with the x, so it's not like super awesome. That's about as hard as it gets. This is gonna be similar to number 1. Yeah, let's do number 4. So 2x. Right on the y-axis, the x value is 0. So 0, 0, 0, 0, 0. There's gonna be parabolas with the vertex on the y-axis. At x equals 1, the slope is 2. I'm just going to exaggerate it, make it kind of flat because it's going to pick up really quick. At x equals 2, the slope is 4. So make it steeper than that. And then at x equals 3, the slope is 6. So not quite vertical, but pretty steep. At x equals negative 1, the slope is negative 2. At negative 2, the slope is negative 4. And at negative 3, the slope is negative 6. And there it is. All right, number 5. Number 5, when y equals 1, the value will be 0. So I'm going to go to y equals 1 and I'm going to put slopes of 0. I'm going to go to y equals 2 and I'm going to put slopes of 1. I'm going to go to y equals 0, the x-axis, and I'm going to put slopes of negative 1. I'm going to go to y equals negative 1, and I'm going to put slopes of negative 2. Just make it steeper, but more negative. And then finally at negative 2, the negative 2 minus 1 is negative 3. So steeper in the negative direction. And there it is. Depending on where your point is for your function, I can tell that I have a horizontal asymptote at y equals 1 for the function. If you read it right to left, it goes down forever. Unless you're right at y equals 1, then you're just at y equals 1, just a line. Cool, right? All right, look at this number 6. don't freak out. Go a quadrant at a time. Maybe it's the better way to do it. Where this is undefined, you're not okay. I'll just tell you this. I spoke to different professors, and I trust more Dr. George than, and I'm not going to name the other professor. They both had, these two specifically had doctorates. And this, specific doctor told me if the denominator is 0, that I should be putting vertical tangents. But your function's not always defined. Like, what if I have a vertical asymptote? Do you know what I mean? So if your derivative is undefined, like, see, it's undefined when x equals 0, then you should not be putting any slopes on x equals 0. Because it's possible that I could have a vertical asymptote. Like if let's say the original is like 1 over x, well, that one looks like this. See, and there, like that function y equals 1 over x, and I have nothing on the y-axis. So you should not be putting vertical tangents because there's nothing there. But if I have a function, I'm just making up some function that looks like that. Now dy dx is still undefined at that blue dot, but the tangent still looks like that. But that one does have a tangent. So that one you could put a vertical. Like, am I making sense? Yeah. But College Board will not try and trick you. So I trust Dr. George better. If it's undefined, don't write anything in there. As a matter of fact, they won't even put lattice points in there, and you'll see in a little bit because we're going to do a free response question. We're going to do a real one. That's just for the record. I think Delta Math might put them in there. If bless you, I'll check to see if they put them in there. If they do, I'll delete those questions. All right, ready? So the first thing I'm going to do is I'm going to plot the points where it is 0. So it's 0 whenever the y value is 0. The y value is 0 all along the x-axis, but be careful. Do not put one at the 0, 0. 0 here, 0 there, 0 there. 0 there, 0 there, 0 there. Don't put a don't put a little mark there at the origin. So far, so good. Okay. Now I'm gonna go to, let's see, what am I gonna go? We're gonna choose points. I'm gonna go to 1, 1. At 1, 1, 1 divided by 1 is 1, but I have a negative in the front, so it's gonna be -1. I'm gonna go to 1, 2. 2 divided by 1 is 2, but I have a negative, so it's going to be -2. So just make it a little steeper than that one. Now I'm going to, let's see, I'm going to go to 2, 1. So 1 divided by 2 is a half, but -1/2, so flatter than the one that we have to the left. And then I'm going to go to 3, 1, and 1 divided by 3 is 1/3, but a negative, so -1/3, even flatter. Cool. Now I'm going to 2, 2. 2 divided by 2 is 1, so -1 again. And now I'm going to 3, 2. 2 divided by 3 is 2/3, so a little more flatter. And there it is. I got all quadrant 1 done. Cool. Let's go to quadrant 2. -1, 1. 1 divided by -1 is -1, but I have a negative in the front, so it's going to turn to positive. -1, 2. 2 divided by -1 is -2, but times a negative, it's going to turn to +2. See? -2, 1. So 1 over 2 is -1/2, then times a negative, so +1/2. -3, 1. So 1/3 negative times a negative, so +1/3. So there it is. I still got 2 lattice points to fill in, so let me go to -2, 2. So that's going to be -1 times -1, +1, so +1. And -3, 2. So what's that? 2/3, +2/3. Flatter. And there it is. We got quadrant 2 now. All right, now I'm going to go to quadrant 3. -1 is a positive, but divided by a negative is back to a -1. -1, -2, that turns to a +2, but then divided by a negative is -2. So more steep but negative. Now I'm at, where am I at now? -2, -1. So 1/2, -1/2. Right? -3, -1. So 1/3, -1/3. It's flatter. And -3, -2, so -2/3, -2/3. So that's 1/3, -2/3. And then -2, -2, so -1. -2, -2, +1, then times -1, -1. There it is. Yeah, it can be a little tedious. Don't worry, they're not going to ask you for a whole bunch of crazy points. They're going to make it more obvious. All right, now one last quadrant. One last quadrant, guys. 1, -1. -1 by times a negative is going to turn to a positive. +1. And then let's see. Since I already started at 1, 1, -2. So -2, so +2. And now I'm at 2, 1. So that's going to be 1/2. And now I'm at 2, -2. So that's going to be +1. 3, 1. That's going to be 1/3. And 3, 2. That's going to be 2/3. All right, there it is, guys. And yeah, we got it. We got the gist. How do we feel?
Oh. So, are we ever? Is this as far as guessing? We're never gonna have a real world application.
No, we will. Oh, you know what? Let's talk about that. Have you ever seen this in the real world?
Yes.
Where?
Zero.
Yeah. Do you remember? Have you guys ever watched the Weather Channel or the news? Do you ever see when they do like wind velocities? And do you know what I'm talking about?
Yeah, and they have like the little.
High-pressure storms coming
Yeah,
down.
and you see the little lines all together. Yeah, that's this. The only difference is sometimes they put little arrows to indicate like the direction of the speed. When you take something called vector calculus, for those of you that are going into STEM, it's the same. These are the vector fields are slope fields. I don't have internet connected to this, but I can connect it real quick and I can look at like a. Should I do it real quick? Okay, well, don't worry, we'll do it eventually. I'll send you guys a picture of when I watch the news tonight, and I'm gonna say, "Look, slope fields," and I'll do that. All right, here we go. These are kind of fun, guys. Have you guys come into slope fields in your flashcards yet?
No.
No?
I don't think you put them on there.
No, I thought I did. I thought I put all the.
Does more topics be honest? Yeah, do you? It like adds on before they get, does it? Or how is it?
No, I click on like what like what
Yeah, but
to
as
test.
you go, like it's all shuffled.
Like,
in.
Yeah, it's all shuffled.
Then no. Yeah.
Huh?
I was about to say,
Okay,
because,
maybe-
I did like 60 last time. I didn't say 60.
Maybe I didn't click on it on purpose. But after today, you're gonna start seeing them. I'm gonna go in there and I'm gonna click. It's all I gotta do is click one button. It's a menu and I can click what topics and I just push all of them. I'm just gonna push the button off. Okay. Anyways, here we go. No, because then you'll have BC questions. No, I'll just keep it with AB. All right. Match the slope fields with differential equations. Here we go. Number 7, sine x.
Oh, this is cool.
So I'm looking for something that goes. I'm looking for something that goes back and forth. A, B, C, or D? Which one? C.
Bryce, I've seen it.
So 7 is C. 7 is C. Yeah, perfect. Number 8. Oh, child, I don't know if I can tell that one. Here's how you can tell number 8. I always like to say I'm going to equal that to 0, and I'm going to first find, now this one is y equals x, I'm going to find where y equals x. Because I know that that's where I have slopes of zeros, and I already see it. Look at that one right there.
Oh, I see.
And then I see, okay, to the left of that, I better have negative slopes because it's x minus y to the left of that. And then to the right of that, I better have positive slopes. And sure enough, I do. Do you guys see it?
Yeah.
So what is that one? D. When I say to the right, I'm talking about to the right of like the line y equals x. Okay. So here we go. Now let's go to the 2 minus y. The first thing I'm going to do is I'm going to say, okay, well, I'm going to equal this to 0. So I know that at y equals 2, I better have slopes of 0. And I can already see it. Which one? A. Notice that if you're above the 2, I have negative slopes. Is that accurate for this? I'll say it again. Notice that if you're above 2, that you have negative slopes. Are you shocked? No, because if you're above 2, that means 2 minus 3, 2 minus 4, 2 minus 5. And 2 minus 3, 2 minus 4, 2 minus 5 is going to be a negative number. Okay, perfect. All right, and then the last one, the last one, dy dx equals x. Well, let's see. That one, look, there's no y's, so it has to be letter B. Chav, why? What? Just because it's the last one? Notice, look, I'm circling this right here. Notice it doesn't matter if you go up or down on that line. All the slopes are the same. Do you guys notice that? Because that means y is not affecting it. It doesn't matter. Like, oh, I'm at 1, 0, the slope is 1. I'm at 1, 2, the slope is still 1. I'm at 1, 3, the slope is still 1. Like, it doesn't matter what the y value is. It's not affected. Do you guys see that? Notice that from the y-axis, everything to the right of that is positive, and as you go further right, it gets steeper and steeper. Notice from the y-axis, if you go to the left, I have negative slopes. If you go further to the left, the slopes are getting steeper and steeper because the magnitude is larger but negative. Does that make sense? Yeah, so we're not robots. So I think we're doing good, guys. All right, now let's go to number 11. Oh, it's the same thing. We're still doing matching. All right, number 11. I'm going to look. Which one do you think it is? Yeah, you're right. How did you get B? Yes, that's what I did too. I did exactly what Estrada said. I don't know if he did it that way too. When x equals 2, 2 times a half is 1, 1 minus 1 is 0. So I looked and I'm like, hey, look at that. That looks like that's 2. And I know that everything larger than 2, I'm going to have positive slopes. And everything to the left of x equals 2, I'm going to have negative slopes. Do you guys see that? So number 11 is letter B. What about 12? Yep, 12 is C because it's only affected by y and not x. So above the x-axis, my slopes are positive. Below the x-axis, my slopes are negative. Are you guys seeing that? What about 13? D. By the way, I don't know if you guys recognize this, but notice if I have a point right here and they were to tell you how does this function look? This function is a circle. So if I were to tell, so are you shocked that it looks like negative x plus y? No, look, check this out. X squared plus y squared equals r squared. This is a equation of a circle centered at the origin where r is a constant. If I were to take a derivative with respect to y, look at this. I'm going to move the x squared to the right. Y squared equals, because I want to make sure to connect everything, r squared minus x squared. I'm going to, should I do a derivative right now? Square root? No, leave it like that. I'm going to take a derivative with respect to x. 2y dy dx equals, the derivative of r squared is 0, is negative 2x. Are we still okay? I'm taking the derivative with respect to x, guys. Divide by 2y, divide by 2y. Look at this. dy dx equals negative x over y. OMG. And we just said this is a circle. Notice how everything is connected. Isn't that cool? But do we get it though? Like we're not, like I'm trying to connect everything from the past to the present. Okay. Man, that's what I'm going on very little sleep. I don't know how I woke up all of a sudden. All right, the last one, x plus y, again, that's what I'm going to do. I'm going to equal that to 0. I see that y equals negative x. Just like before, I see right down there, right through y equals negative x, I see slopes of 0. So 14 has to be A. Yay or nay? All right, I think we're doing good. Relax, we're good. This was from a course description, from an old course description. It says, the slope field from a certain differential equation shown above, which of the following could be the specific solution to the differential equation? Does it look like I have a y equals x squared embedded in that slope field? No, out. Does it look like I have an exponential? Y equals e to the x looks like this, by the way, in case you're wondering. Hopefully you remember. Looks like that. And I can just shift it up and down depending on what the c is. Right? Does it look like, well, y equals e to the x literally looks like that. Does it look like I can fit this curve within that slope field? No. So what about y equals e to the negative x? That one looks like this. You think that one goes in there? No. That one's out. What about letter D? No. Y equals ln of x is the only answer choice. By the way, in case you don't know, which I hope you do because we're in calculus, y equals ln of x looks like this, guys. And sure enough, they don't show you below the x-axis here. But yeah, this top part looks like it fits in here. Look at that. Do you see that? I just drew my little arrow in there. So see that, definitely that top part looks like that top part. Okay, awesome. Look at number 16. It's the same type of question. The slope field, so does number 16 look like it could be a sine x? No. Does it look like it could be a cosine x? No. If you deleted sine x, you should delete cosine x. Because it just goes up and down, up and down, up and down. Does that look like it goes up and down, up and down, up and down? No, it looks like this to me. If I'm looking at it, it looks like I have a horizontal tangent right on the y-axis. It looks something like that.
I'm saying D.
So which one does it look like to you? D.
I was looking at it and I was like, this is like an odd.
Good. Odd function.
Oh, I saw this will help.
Yeah. This will help with all of this. This will answer your questions. This will answer your questions. All right. This FRQ is from what year? 2016. I haven't looked at the rubric yet. I will look at the rubric once we do this. You guys ready? On the axis provided, sketch a slope field for the given differential function equation at the 6 points indicated. I want you to observe something. Do they put any points at x equals 1? No, they're not going to try and trick you. Notice dy dx is undefined at x equals 1. Are we cool? All right, here's what I would do first. What would I do first? I would plot where the points are 0. That's really simple. All I got to do is find where y equals 0 because I have a numerator of y squared. 0 divided by anything is 0, right? So where is y 0? Right on the x-axis. 0, 0. Do not put a 0 at x equals 1. Just at the points indicated. Are we okay? We got 4 lattice points left. Go slow. Go one at a time. Let's go to, which one do you want to do first? The 0, 1? Let's go to 0, 1. So I'm going to go over here, dy dx, evaluated at 0, 1, just so you can see the work. You don't have to show this. This is just for you guys. 0, 1, and I'm going to plug in 1 squared over 0 minus 1. So 1 divided by negative 1. So I get negative 1. Put a slope of negative 1. Let's go to the 0, 2. dy dx evaluated at 0, 2 equals 2 squared over 0 minus 1. So I get negative 4. It's all good. It's all good. So put a slope of negative 4. Chubb, I need a ruler to measure. It's all relative, guys. So just make sure that it's steeper and negative. Cool or not cool? All right. We got 2 more points. Go to 2, 1. dy dx evaluated at 2, 1. Guys, you don't have to write this down. You can just look at it and do it. But I just want to make sure that you guys know what's up. 2 minus 1. 1 over 1. What's that? 1. So a slope of 1. So make it look like the other slope in terms of steepness, but positive. Positive slope. All right. Go to 2, 2. dy dx at 2, 2. 2 squared over 2 minus 1. 2 squared is 4. 4 divided by 1 is 4. Make it look the same steepness, but positive. And there it is. I do not remember how many points. Usually these are like 2 points. Sometimes 3 if they tell you to put a curve through it. That's it. Cool or not cool? Okay. Well, on this one that you wouldn't because we don't know what's going on at x equals 1. But it has to be some type of question that it's very obvious. You'll see it on delta. I put some on delta. By the way, the delta assignment, it's a lot easier if you have a mouse or if you have a touchscreen with your finger. Okay, let's do the next one, letter B. Let y equals f of x be the particular solution to the given differential equation with the initial condition f of 2 equals 3, so there's my initial condition. Write an equation, Write an equation for the line tangent to the graph at x equals 2. Use your equation to approximate f of 2.1. All right.
X. Ooh, I remember the loop.
Tangent line, and then use that tangent line to approximate. Do I have enough? What do I need for a tangent line? Point and slope. Do I have a point? Do I have a slope? Yes, I can get it. Look, guys, they give it to you. dy dx equals this. So here we go. Here's my point. I'm going to go 2, 3, and I'm going to go dy dx evaluated at 2, 3 equals, and I just plug in 3 squared over 2 minus 1. X minus 1? Yeah. So 3 squared, 9 over 1. So 9. My slope is 9. Cool or not cool? Here's my tangent line. Y minus 3 equals 9 parentheses x minus 2. Are we still okay? All right, move the 3, and what am I going to plug in for x to approximate it? 2.1. So I'm going to write f of 2.1 is approximately 9 parentheses 2.1 minus 2, close it, plus 3. Do I have a calculator or no calculator? Okay, if you are scared, can you leave it like that? Yes, I encourage you to be courageous, but if you are scared because you just want the points, you can leave it like that, but I encourage you to keep going. So let's see, 9 times, that's 0.1 plus 3. 9 times 0.1, I want to say that's 0.9, and then plus 3, so that's going to be what, 3.9? There's my answer. How do I feel? How do you feel? Guys, I'm still like asleep here.
No, that's for probably getting you.
Okay.
That's probably why you feel really good.
Well, I love math too.
That's why you were speaking so fast. You're like,
All right. Miss, I'm gonna beat you up. Oh, sorry. YouTube, I did not say that. All right. I would never. All right. All right. Yeah, make sure I edit it out. No, leave it? All right, I'll leave it. YouTube, I would never beat anyone up, for the record. All right. No. We're good. We're good. All right. Last one, guys. Last one. Focus. All right. So now it says, look what letter D says. Find a particular solution to the given differential equation with the initial condition f of 2 equals 3. This is what we were having issues with last time. Let's see if we can do this. Ready? So I start with dy dx equals y squared over x minus 1. Y squared over x minus 1. All right. What is the first move? Y's with the y's, x's with the x's. That's called separable differential equation. That is a point right off the bat, more than likely. So I'm going to go x minus 1. Oh, so I'm still sleepy. Yeah, I was testing you guys. 1 over y squared dy equals 1 over x minus 1 dx. You can also say y squared, dy over y squared and dx over x minus 1. Same thing. Are we okay right here? All right. Next, I'm going to integrate. Go slow. The antiderivative of 1 over y squared is? Perfect. With a negative in the front.
Yeah.
Perfect. Oh, shit. Sorry, I didn't hear you. Negative 1 over y equals, what's antiderivative of this expression?
Oh, ln of x minus 1.
If it has no limits, put absolute. Oh, yeah, you're right. But x minus 1, close it, plus c. Does this look like a good point to find your c value? Yeah, it does. Let's plug in our 2, 3. So I'm going to write, let's see, 3. Negative 1/3 equals ln of 2 minus 1 plus c. I took out the absolute value because it's still positive anyways. So now I have negative 1/3 equals ln of 1, which is 0, plus c. So c is negative 1/3. Dang, I should have put more space in here. That's fine. Negative 1 over y equals ln of x minus 1. You can take out the absolute value because we're working with positive values anyways. We're working for x greater than 1. So if you want to state that somewhere, x is greater than 1. Because of that right there. Minus, where are we at? 1/3? Okay. How would they probably do it? Okay, I think they would probably do it the simple way. You guys want to see the simple way? Yes, we are going to do the simple way. I want to get this. First of all, let's get rid of the. Should I get rid of the negative now or later? Now? Okay. Let's do it now. Times it by negative 1, times everything by negative 1. So here's what I have now. I have y equal 1 over y. 1 over y equals negative ln of x minus 1 plus 1/3. Are we still okay? Okay. Here it is. Here's the simple way. I already see my answer pretty much. All this is over 1. So do that. Flip it. And that's it. And that's your answer. So that means I'm going to have this. Here's my final answer. Y equals 1 over negative ln of x minus 1. Make sure that negative doesn't float. Make sure it's right in front of that ln. Plus 1/3. Or maybe put the 1/3 in the first so you know that that's a negative. You guys know what I mean when I say that or no? Yeah, here's what I mean when I say that. Like, don't let it float. And I'm going to write it way over here in blue because it's not part of this. If you write it like this, the reader cannot tell if you are saying that the negative is the ln or if you're saying that all of this is negative because you let the negative float way out there. So either put it right in front of this like that so there is no discrepancy, or what's an even better way? Put the parentheses or put the 1/3 in the front minus ln, and then there is no discrepancy. That is he saying that the expression is negative? No, there's no discrepancy. It's ln that's minus. Do you guys see that? So yeah, so to make sure that that negative doesn't float, guys. Should we look at our rubric?
Yeah.
All right, I'm excited. I'm excited to see how we did on this one.
I want more free response questions like this.
Well, we are. That's all we're doing now from now on.
Honestly, like I prefer these over like having like
Yeah,
why this means
justify.
this. Something wrong. It's like
Do they give us the justifier on the ones that are like calculators? Are those when we get like the justifier?
would we have slope
I
field?
don't think it matters.
Would we have like these kind of like slope field questions on a calculator section?
Remember your mock exam? I'm sure you had one at least.
I don't remember that.
Well, we could
Would
use
it
calculators.
Or no, we
What
don't.
will we need it for?
Well,
Use a calculator?
what if they ask you a question?
Usually these are going to be in the no calculator.
These are the
Yeah.
Usually. All right, here we go. Letter A. They give you 2 points. One for 0 slopes and one for non-zero slopes. And there is my little, that's all you got to show. And there it is. You got 2 points. Letter B. One for tangent line equation and one for the approximation. An equation for the tangent line is y equals 9, x minus 2 plus 3. Awesome. And then f of 2.1 is approximately, notice they use the approximate symbol first, and then all that expression equals 3.9, 3.9. We got 3.9? Perfect, we got it. Letter C, look how many points? 5. Let's see how they break it down. 1 point for separation of variables. So just separating the variables, they give you a point. Isn't that awesome?
Yes.
1 point, or 2 points for the antiderivative, so probably 1 and 1. So antiderivative of 1 over y squared is negative 1 over y. And then 1 point for the antiderivative of ln of x minus 1 plus c. What's up?
So then, when we were doing our work, I don't know, maybe it was just me or I missed it. We just did the antiderivative into the same line where we separated the variables. Should we just repeat that to keep that like
Oh,
itself?
you're good. That's my habit, and I can. If you feel compelled that you want to write like a new line,
Yeah.
you can. Like this, like the way they did it. You can. No. As soon as, like, let's say you didn't have the top line, but you had this bottom line, that second line with the integrals, you already separated your variables, and now you're doing the antiderivative.
Okay.
So, yeah, she asked if you want to have, if we should do a new line. You don't have to. All right. No, I mean, as long don't no, you're not going to get more points. All right, so there it is. They got the C value, constant of integration using initial condition. We got the 1 point. Solves for Y. Notice that solves for Y is just worth 1 point. So even if you mess up with the algebra, you can get all the other points. Do we get? Oh, look what they did. They put the 1/3 in the front, so there's no confusion. Y equals 1 over 1/3 minus ln of x minus 1. We got the same. They put the domain here. You don't have to. The solution is valid, but don't worry about that. We're good. Well, do worry about it, but you don't have to be that explicit, that specific here. Look, I want you to notice the note. What does it say for the bottom note? If you do not separate the variables, you don't get any points. Why do they do that? Because they recognize that some students know, maybe not for this one, but like let's say you had dy dt equals ky or something. Some students can just go right off the bat and go, oh, dy dt equals ky, it's an exponential function. Y equals, and then just write it out. So you got to separate the variables. If you don't have a C, if you have no constant of integration, the most you can get is 3 points. Probably the point for separation of variables, of the y's with the y's, x's with the x's, and antiderivative points. So there are 3. Because you didn't even take your initial condition into account. Okay, that was a lot. How do we feel? All right, we have a delta math over slope fields. It's not hard. It's not difficult, but if you don't have a mouse, it can be kind of hard. But if you have a touchscreen, it won't be bad because all you're doing is. And that's it, guys. We're done. I'll see you guys tomorrow.
I don't have a touchscreen or a mouse.